Hello, welcome to the mining match. We start by announcing Spanomine. If you are in the mining industry and you speak Spanish, you should join Spanomine. They provide professional development and connections to the Latin American community. Today we will discuss about technology. Have you heard about artificial intelligence? Well, in the mining industry, there are many challenges that require technology, and artificial intelligence offers great solutions and fast implementation of systems that can help us to do our daily operations more productive with less cost. And that is exactly what we will discuss today. Using artificial intelligence to maximize production and reduce drill to mill cost. Our speaker today, Ravi Sahu, is joining us from Buffalo, New York. He's the founder and CEO of the company Strayos. Strayos is having a great experience helping miners to improve their operations through the application of this technology. Well, without further ado, I'm going to now transfer the microphone to Ravi.
Well, thank you, Alan, for having me and for the opportunity to share what are the applications of AI in drill to mill. And this is a very fascinating topic for me to not only present, but also what are the outcomes that can be gained for the overall mining value chain. And we have a lot of areas that we can cover here, but I have picked a more specific use cases here, how we can leverage the data and on top of build AI applications for very specific drill to mill scenarios here. Uh, just an introduction about myself. So my name is Ravi Sahu, and I'm the CEO of Strails. And what Strails does is it helps mining operations to optimize their site. And we do this by having the data that has been collected either through visual imagery as well as the sensor data. And our platform takes all this information that can be applied for optimizing drilling, blasting, loading and hauling process, as well as the downstream operations, which is the post-blast assessment, as well as the crushing and milling productivity analysis. So without further ado, I want to talk a bit more about how we got started here, a little bit of preamble here. So today's agenda is, we're going to touch a little bit more on what we do as Extrails and dive right into the topic today is what maximizing production means in different scenarios and why to use AI and whether to use AI or not as well and what is enabling AI in different scenarios. So what are the driving factors and how AI can transform drill to mill operations here. And finally, we're going to look into the use cases and the value from AI. And then obviously we will have a Q&A after that. Bit more about Istreos. It's founded in 2016, and roughly the platform is used in 8 different countries and 550 mines and quarries as well, with ranging customers from 50 plus customers from operations from large mining operations to quarries and aggregates as well. And we have teams in 4 different locations in different time zones. That gives us an ability to do 24 by 7 customer support. But one of the key factors that we solve through our platform is how we can reduce drill and blasting cost and then improve the overall yield or the ore quality as a end outcome here. And so we will talk more on that, how it actually happens, not only just to the platform, but general use cases here. So let's discuss a bit more about what maximizing production means. And this is a very subjective topic because maximizing production means different to different operations. At the end of the day, it's a balance act. But how the way I look into is the maximizing productions or the perfect ton is if you can maximize your safety, your minimum effort, and then the profit that's coming out from the operations. That's what the maximization of the production looks like here. Because if you're not balancing all these three things, then the production itself can be achieved, but we may cut corners on the other areas here. But how AI and machine learning can help you get there. And the way I think it is the more of what you want and the less of what you don't. It could be a reduction in oversize or fines in your drilling and blasting, and how to get there and how data can solve these problems here. Uh, Traditionally, if you see the drilling and blasting activity is much more of a based on the experience, based on the art, I would say, where a blaster knows about their site and they know exactly what equations to put in and how to design things. So all they have a lot of experience that they are working with, and they can use those to control their specific empirical parameters or like empirical formulas that they use to design a specific blast, and it works well while there is uh, more of these design parameters, but it's more of looking at what worked for that specific blast, and then they are starting a new blast from the scratch. There is no learning that can be done of how my historical blast can lead to the better blast for the future ones, right? So blasters can control all the parameters that's in their hand, which they are operating with, and then they account for the other types of geological parameters like rock strength, joint spacing analysis, as well as the depth, borehole depth and the deviation factors. But still, the information is for that specific blast or for that specific production, but not looking at the overall holistic perspective. And that's where the applications of historical data to put into use for the AI comes into the picture. And that's the case here is why to use AI. But let's go into what are the maturity curve of AI in mining. We see a lot AI as a buzzword in many other industries, but where we stand in mining here. Uh, and but before we actually look into the maturity here, it's important to understand what AI itself is. Right, a lot of the times it gets a bad rep that AI is going to come in and make things redundant in the mining industry or take away jobs. But I think it's more to that. More the way I look into AI is it's going to enable much more intelligence and experience, and it will augment better experience for the mining engineers or anybody on the operational side who are working. Because it's just AI is necessarily is the programming of algorithms that mimic human thinking, and this thinking can be applied at a scale. And these algorithms are programmed to operate within a specific type of data sets. Once the data sets are programmed, you can train for different type of scenarios to find anomalies, and you can test every possible combination at a speed of millions, per million times per second. And that's what the power of machine learning and AI is. Once the algorithms are trained, it can be applied to many, many different scenarios to test many, many different hypotheses. So going back to the blasting example, we looked at design scenarios for only one blast, but what if you can apply a million different types of scenario analysis for that design parameters, how it would look like? And that's what the AI is enabling the decision making for that blasting engineer there. Same thing, I think I love this analogy of how Thomas Edison kind of found 2,000 ways to kind of, not to make a light bulb, right? But you only needed one way to make it work. And that's what kind of, the AI scenario modeling, will help you get there. Talking about the maturity curve in mining, this is from the Global Mining Guidelines group here, which essentially they've described the category levels of the artificial intelligence, assistive, which more of what you're doing on a daily basis. And a lot of the times we don't even know, and we are writing many AI programs of automating our own task. And that's what this assistive part comes in when you are trying to automate your day-to-day job to write some macros, but at a very small scale. What if you can apply that macro to, like, 1,000 different permutation and combinations? So that's what assistive intelligence looks like, augmented when you are enabling both the algorithms and AI to learn from each other. So AI finds anomalies and humans validate it, but AI finds, a few other anomalies, and humans can glean insights on that anomalies together. And the next level of the maturity curve is autonomous intelligence, which means machine vision, or machines itself can not only see and understand, but also able to correct things. Typical examples could be your machine vision systems in ore sorting. It's seeing, it's correcting and sorting and passing into right bucket. And then not only that, it can alert the plant manager about any issues right at the sorting level. And that's what the autonomous intelligence, comes in. But why, the use of AI could be more beneficial here? Because the way we see it is, the mines are a constantly moving factory. It's a complex environment and complex enterprise. You have um, drilling and blasting going on, lots of data being generated there. Blasting not only is moving the rock on the ground on a daily basis, but the transportation or the loading is a huge, huge factor, how you optimize your production and the cost. So which is leads to the downstream part of also how your mills and the crushing activity needs to be set up to also optimize the cost there. So it's a very complex environment, and if the upstream and the downstream are not connected, it can lead to all this, data silos. But what is enabling AI to maximize the production here? And the way we think about this is the data. Now the mines are generating data that we have never seen before. And these are all possible because we have data sources from not only laser scanners, drones, satellite, now your phones, which are kind of, are on your pocket. You can document things, you can collect not only the pictures, but also the latest version of iPhones have LiDAR sensors, which you can enable to collect, survey information. And then the obviously LiDAR hyperspectral is another form of data source, which can help detect mineralization layer and the ore bodies. Thermal sensing, which is understanding of the gas emissions in the blast. So all this data, what we call the visual data, more of a, which has an element of pixel or the spectral bands associated with it. So it's a computer vision data. So recognizing the patterns from the pixels and the wavelength. And then the other types of data is machine sensors, which is directly coming from your equipments, smart drills, downhole information from your measure while drilling, crusher data, as well as the IoT sensors that's been installed in various parts of operations in the mine. Other types of data is spatial data, which is your surveying or the RTX corrections from the network. And then the subsurface data more on the electromagnetic side or your geological modeling, more of a geophysics information. So it's generating data at a pace that we have never seen before. And if we don't structure in a way to make use of it, it's going to go wasted. And I read somewhere, this, and which kind of really resonated with me, that we as a human or human brains are not good in retaining information over a long period. I couldn't remember what I read, 5 years ago, and maybe bits and pieces, but human brains are really good in generating ideas. Or I always remember the ideas that I generated, even like 15 years ago. So this kind of proves the point is our brains are wired to be more creative and more, it strives more towards new types of idea generation and new types of concept and systems thinking. But doing a dull and routine task that doesn't retain over a longer period, and that's where the AI can come into the picture to take and automate those things here. But that itself doesn't solve the problem by itself, right? Your data for AI to work needs to be structured. And the problem with a lot of the enterprises with the mining is they have these data silos because the data is coming from different sources, as we saw, computer vision, spatial data, sensor data, and it has its own set of tools. And it only sits in those tools, those data, and you cannot make really the drill to mill types of optimization, from that. So you have resource planning as one silo and one type of application. Mine planning is happening at only a mine engineering level, which is just looking at plans, but the geology survey and all those are disconnected. But then organizations are also taking next steps towards integrating systems, so which means integrating third-party systems with one another, which means I can integrate my surveying information to my geology or mine planning, but it only connecting with two silos together, not unifying it. And the way to look into that is moving to the next enterprise level is you have your resource planning, mine planning, geology, and surveying, as well as any type of time series data that's been collected by these sensors are connected together. And that's what kind of moving from siloed organization to a unified enterprises here. And that's is making possible through the implementation of AI, can not only bridge the data silos, but also help generate contextual intelligence. So moving from the understanding of what happened, if I look into my specific drilling or blasting activity, or after the blast happens, I know what happened by utilizing certain systems. I can measure things, which most of the mines do, what happened, but why it happened, like really going to that level of granularity, and then taking the one step further, not why it happened, but also running what if scenarios, like what could happen next. So that's where we can move from complex enterprise to a streamlined enterprise. So let's talk about like how we can apply AI in drill to mill, and how the continuous optimization looks like in each step of the process. And this continuous optimization is not a new term. It's been around from several decade ago. Through we have it's more of a Kaizen term where looking at continuous improvement, but applying into this scenario is you have your survey and planning data that can be rolled in, and you can apply that further The AI can detect the geology, and then you can use the geology information to plan your drilling better. Further, after drilling is happening, or even during the drilling, you can get the data such as measure while drilling logs to understand the rock strata better. And now I have a better understanding of down the whole rock strata. I can design my blasting operations better. So your timing can be perfect, your loading explosives density can be perfect, and you can predict what types of muck pile shape I am going to get, what type of fragmentation I will get, and you can do what if scenarios on the cost as well. If I use this type of explosives, if I, on this type of geology, with this type of drill planning, where I would get and lead to. And further to that, how would I optimize my loading and hauling? If I am a loader or excavator based operations, what's my shape? This type of diggability would lead us there. And then after the post blast, you can have a further assessment done on the processing of the materials as well, that can be tied to the throughput of the your milling side, mill throughput here, and reporting as well, which is looking at the commercial part, how this entire each hole drilling led to what type of production and how much the cost was associated with it. So this data now, since you have operated in one single place, it's creating this data lake, and it's giving you the granular information automatically. Every time you put a data, it's recognizing what drilling and blasting scenarios is leading towards, or my fragmentation with drilling and blasting is my powder factor is going up or down. So those scenarios can be done. So you can do not only the analytics, but run scenario modeling through taking it to identify what's the type of ideal design parameters would let me save cost, but also maximize my production. So all the scenarios can be done in one place. And now let's talk about how AI can transform overall drill to mill here. So when we think about the drill to mill, is not only looking at the data from one specific operational perspective, which is upstream, looking at drilling, blasting, downstream, post blast, but also the situational awareness. And this continuous situational awareness is what we can leverage AI, the computer vision AI, which is if you are doing regular surveying, visual inspections of the site, those data can be fed to identify different types of situational awareness intelligence for the engineers on the site. So looking at what's my geometry of every time I do a drill and blast, how my elevations are getting impacted, what's my structural stability looks like, what's my seam in this specific bench or high wall is moving towards. So what's the bedding plane direction looks like. And these all situational awareness can be combined together in overall feedback loop here. And that's what I see this as like the secret sauce of AI. And once you have this information, such as your input data in terms of your design, which is what's the drill pattern layout is, explosive selections, and the timing plan. After you have executed the design, the QA/QC data can be brought in, and that can be generated in one place to derive contextual types of information. So like geotechnical data, AI, which auto detects the issues in your bench face. If you have measure while drilling analysis or ore zone data that can be brought in together as an input, and that you can further assess and feed into the AI model. Now it can correlate to your performance data with what specific design parameter what's my blast results looks like here, which is fragmentation, muck pile shape, your diggability, vibration issues that might happen. And the value chain kind of, information can also be brought in here, like dig rates, crusher throughput, what's the yield and the recovery is, and then the cost information overall for that operation. Once you have this, you can run a feedback loop in AI, and this, by the way, is all automated. Um, that's what the power of AI is. It's the data is just floating in and creating this feedback loop, and it's running several combinations and trying to find a pattern that can give you the optimal result. So you just do an input variable, and the output variable can find out, like, if I'm trying to optimize my cost, profit, which is the profitability, safety, and then also the production efficiency, how it will get there by running different scenarios. So the way we look into this is not just the cost reduction, but also the throughput uplift. And we've seen AI optimization can gain up to 5 to 20% improvements overall the total site. So cost reduction is in the areas of drill and blast cost, reducing obviously secondary breakage costs, loading equipment wear, which means if you have generated a perfect shape and then the desired fragmentation, obviously your loading and hauling will improve, and you have less wear and tear on your equipment. The throughputs as well. So diggability improvement, and then the downtime that usually is an added impact that comes in sometimes if you have oversize, issues. And all this can be further used to pass on into honing the new type of like data sets, right? So in terms of this drill to mill AI scenarios here or model, you have the data at a site level. Now going further, this data can be utilized overall broader at the industry data, which is the geological AI models, your equipment data, blast performance data, as well as the geospatial data, which is the more of a location data, combining together and calibrate to your specific site and how your specific site will behave on the parameters that you have given, and further optimize your specific site. So this is one use case, from one of the operations, how the implementation of AI can help them of increasing not only the production, but also the data collection became autonomous, and the identification of the underlying types of materials better, which helps them increase the drilling and blasting outcome up to 60%, and then 12% recovery in the ore loss that they were earlier receiving, which had an overall drill to mill kind of cost savings of up to $1.2 million, as since they were able to optimize the drilling and blasting outcome, their all of a sudden their energy savings at the plant started to shoot up because their crushers were taking less energies to crush. And this is a core operation scenario. But not only that, this drill to mill scenarios and the optimization goes beyond just the drill to mill. So you have safety improvement that you can bring in if you're constantly monitoring and feeding the data, your visual data through drone pictures or the hyperspectral data. It can help your slopes better, as well as the automation of the inspection of the road grades, and then identification of the unsafe locations as well. And you can remove personnel from there. Understanding of the environmental side, which is measuring the biodiversity and planning, for that. The reduction of carbon emissions. We looked into the haul truck side where how you can optimize your road grades and tie the data into the data coming from the truck tire sensors to optimize not only the roads better or design better, but also how to optimize the truck performance better. And that is a direct reduction of carbon emissions there. And then the community side as well, which to managing the community part, if you're uh, quarry operations, that's one of the major concerns. How, how the drilling and blasting can not generate issues in the community. Most of the sites are nearby. How the prevention of damage to these sensitive locations can happen effectively and a much more optimized way. But the another way that we see is AI can lead into a creation of new type of highly skilled jobs here. The more we embrace the engineers of today who are operating in mines can take this to leverage AI to build the not only the intelligence on the mind perspective, but also their situational awareness and the decision making part will improve as an engineer. So they can move from designing the plans to actually making and optimizing the designs plan. So the way I see it is like you can mine the plan, instead of planning the mine, you can mine the plan. uh, so now applying AI at a scale here is you can once you have the AI at a scale, you can bridge the gap between upstream and downstream data silos, and it has created this enormous opportunities of data, which is coming from different sources to unify it. And insights gathered from one site can be applied to the other site with a similar type of geology. And also you can glean into what worked well in one scenario, how you can apply into the other situation. So there is no need of kind of one site is struggling or one engineer is struggling on the same issue to having the same problem in the other site as well. So it can drive this optimization overall, not only from one operational drill to mill, but also to the other similar sites as well. So that brings to the end of this presentation. I hope it was useful. Thank you very much for the opportunity to share about drill to mill AI here.